Alright, we are going to find increasing and decreasing intervals, and we're going to start off by finding the critical numbers of y, so where the derivative of y equals 0. So it looks like we've got a product rule here because we've got something times something. So I will start off by taking the derivative of this first part times the second part unchanged plus first part unchanged times the derivative of the second part. Bring the power down, lower the power by 1, and looks like I need to apply the chain rule here. Take the derivative of the inside part, and that would be times a negative 2x. Alright, so that's pretty messy. So before I start thinking about trying to set this equal to 0 and solve it, I want to use some algebra and try to clean this up just a little bit. So over here, I've got the square root of 16 minus x squared, and think of that as a fraction. And over here, if I multiply my numerators, I get negative 2x squared over 16 minus x squared. Alright, I'm going to go ahead and just let these 2's reduce out, so I have one less thing to keep up with there. And I'm going to assume they want us to get a common denominator. So between 1 and the square root of 16 minus x squared, I would need to multiply this denominator by 16 minus x squared, multiply the numerator by 16 minus x squared. That way the left denominator is square root of 16 minus x squared, and the right denominator is square root of 16 minus x squared. Now right here, when I multiply that by itself, that is going to get rid of the square root. This fraction is not being multiplied by anything, so if I don't need to multiply the denominator by anything to get it a common denominator, then I don't need to multiply this numerator. Okay, and then the purpose, of course, of us getting a common denominator is now we can push all of this together. And I've got a 16 negative x squared plus a negative x squared would be negative 2x squared. And I'm actually going to just switch the place of these two, and I'm going to factor out a negative. This guy's still squared. Okay, so not much else it looks like I can do with my numerator, or denominator, I guess, for that matter, just simplifying this. But now I can start to think about critical numbers. Where does this equal 0? Well, a fraction is going to equal 0 when the numerator equals 0. And we got to be careful that it doesn't also make the denominator 0. That would be 0 over 0. But if I multiply both sides by negative 2, and then added 8 to both sides, and then took the square root of both sides, don't forget the plus or minus, and the square root of 8 reduces to 2 square root of 2. So positive 2 square root of 2 and negative square root of 2 over 2. These are my critical numbers. Those are the locations that it's likely to be changing from increasing to decreasing to decreasing to increasing. So now my visual. So my number line, I specifically want to figure out what's happening at 2 square root of 2 before and after, and the same with negative 2 square root of 2. So I can figure out what's happening in between. Something like 0 would be an easy one, hopefully, to work with. So if I evaluate the derivative at 0, over here's my derivative up here. This would be negative 2 times negative 8 over square root of 16 minus 0. Okay, and the main thing is that it's positive. So in between these two critical numbers, looks like the derivative is positive, which means the graph is increasing. Alright, so 2 times the square root of 2. Let's see, if we think about that as a decimal. Alright, so this is approximately about 2.8. So this would be approximately negative 2.8. So if you're a little bit unsure there, just make sure you pick something down to the right. You don't have to pick the number 3. You could pick 4, 5, or 6, whatever. But something to the right of that critical number. You don't want to pick too big of a critical or too big of a number, just because it's going to be a little harder to evaluate. But if I plugged negative 3 into my derivative, or positive 3, sorry, this would be 9 minus 8, which would be 1. So my numerator is negative 2. And if I plug 3 into my denominator, this would be 9. 16 minus 9 would be 7. And the main thing that I care about is that the derivative is negative. So after this critical number, looks like the derivatives become negative, which means it is now decreasing. Okay, so I need to test one more point. I'll go over here and try to test negative 3. A lot of times if you pick the same value as this with the negative, it'll work out pretty much the same. So let's see. Yeah, so if I plug in negative 3 here versus plugging in positive 3, still get the same thing. And if I plug in negative 3 in here versus a positive 3, since it's being squared, it also stays the same thing. So negative means the graph is decreasing. And now for my visual, I can easily say that it is decreasing in 2 intervals, all the way from the left to this critical number, and from this critical number all the way to the right. And the one place it was increasing was in between the critical numbers. So starting at that x value and ending at that x value.